Hi there, welcome to my channel mathssl. I'm speaking Saqib Latif. This is a May-June 2021 NSC exam question. So paper 2. The question says in the diagram TSR is a diameter of the larger circle having center S. Have a look here. So the larger circle TSR. So the larger circle, this I highlighted, TSR is a diameter and S is the center. The question says chord TQ of the larger circle cuts the smaller circle at M. TQ. So the TQ cut the smaller circle at M. PQ is a common tangent to the two circles at Q. So the PQ is a common tangent. So the PQ, this red I highlighted, this is a tangent to both circle, small circle as well as to the big circle. The question says SQ is drawn, so the SQ is drawn, S to Q is drawn. So the green one, SQ is drawn. RP perpendicular to PQ and MS parallel to QR. Have a look here, there is 90 degree and the MS parallel to QR. RP is perpendicular to QP here. These blue colors which I highlighted, so MS parallel to QR. This is the information of the sketch. The question says prove giving reason that first question say SQ is the diameter of the smaller circle. All of these questions I will show you how to solve one by one. This is a smaller circle and we need to prove SQ is the diameter of the smaller circle. There are many ways to prove. Let me show you all the way and then you can choose one. The first one, S is the center of the circle, main circle. So then, so SQ is the radius of big circle and the PQ is a tan of the main big circle as well as of the small circle. So the SQ perpendicular to QP, tan perpendicular to radius. So therefore we can say SQ is a diameter. SQ is a diameter of the smaller circle, and we're going to give the reason converse tan perpendicular to radius. Obviously, when you need to prove that SQ is a diameter, then we always use the reason converse. So SQ perpendicular to QP tan perpendicular to radius. This is the reason. Therefore, SQ is a diameter. The reason is converse tan perpendicular to radius. And there is a second method I'm going to show you now. You can choose also that one. Is up to you. This is the first method. According to the second method, if you want to choose that one, if you don't want to use this one, then have a look here. Big circle, this is the big circle. TSR is the diameter. Angle Q1 plus Q2 is going to be equal to 90 degree Y. Angle in the semicircle for the big circle. Now, MS parallel to QR, so which means M2 is going to be 90 degree Y. This is a transversal line, and these between these MS and QR parallel lines, and this Q1 plus Q2 is equal to 90 degree. So this is also going to be 90 degree co-interior angle. Therefore, SQ is a diameter. Why? Because this is a diameter. Angle M2 is equal to 90 degree angle in the semicircle. So we're going to say therefore SQ is a diameter converse angle in the semicircle. Always you have to give the reason when you have the diameter, and the reason you're gonna give converse angle in the semicircle. But if you go diameter, like now this was the diameter, and this angle is angle in the semicircle. But now we need to prove we have the angle in the semicircle, so therefore the SQ is a diameter. We're gonna say converse angle in the semicircle, reverse of angle in the semicircle. So Q1 angle Q1 plus angle Q2 is equal to 90 degree angle in the semicircle. Angle M2 is equal to 90 degree co-interior angle MS parallel to QR. Therefore, SQ is a diameter converse angle in the semicircle. This is the reason. And there is a third method also. You can choose also, or you can give answer according to that. I'll show you now. According to this method, MS parallel to QR. So we can apply prop theorem here, proportionality theorem here. QR parallel to MS. QR long base, MS short line. So these TSR, TMQ. These are the proportion sides. So the TS over SR equal to TM over MQ. So is prop theorem. Corollary of the proportionality theorem is midpoint theorem. Midpoint theorem is if a line drawn through the midpoints of two sides of a triangle is parallel to the third side. So therefore, according to midpoint theorem, Tm is equal to Mq. So now we can say if this Tm is equal to Mq, then from the center, line drawn from the center perpendicular to chord, which means this is your chord now, and this is going to be converse theorem, because we're going to say converse line from center perpendicular to chord. So this is going to be M2 is going to be 90 degree. So now therefore we can say SQ is a diameter converse angle in the semicircle, because M2 is going to be a 90 degree. Then SQ, have a look here, SQ. So this is angle in the semicircle M2. So we can use this as well. MS parallel to QR. That's where TS over SR and is equal to TM over MQ. Prop theorem I explained to you earlier already. SM parallel to QR. Therefore, TM is equal to MQ. I already explained to you. And angle M2 become 90 degree converse line from center perpendicular to chord, and then SQ is the diameter. Why? Because converse angle in the semicircle. This is the calculation. Question number 2, you need to prove RT is equal to RQ square over RP. Let me show you how. So this is the question. RT is equal to RQ square over RP. If you can remember my videos, which is a similarity videos, you must watch properly, especially for identifying the triangles. In those videos I explained how to solve this type of question in details. So now I must remember this one. I can write RT is equal to RQ multiply RQ over RP, because if you need to identify the triangle, so obviously I explained to you on those videos, so you have to break up this square. Now you're gonna cross multiply now. RT time RP is equal to RQ multiply RQ. Now we have to do a reverse of cross multiply. So left hand side second one, and on the right hand side the first one. So this go to left hand side, and this gonna goes to right hand side. So RT over RQ, and the RQ, and then this RP gonna be under here. Have a look here. RT over RQ, RQ over RP. Now we need to see the top is gonna be a RTQ. RTQ. So three letters. So top is a triangle, top triangle, and at the bottom is RQP. So the also three letters. So the top and bottom triangle will work. So top triangle we have RTQ, and the bottom we have bottom triangle RQP. So we need to highlight this triangle. RTQ green one, and then RQP is orange one. So we need to prove these two triangles they are similar. Have a look here, the angle Q3. Must remember PQ is a tangent, common tangent to smaller circle and as well as to the big circle. So this is the code now, QR, and this angle Q3 here, this angle Q3 is gonna be a, there you can see, forming another angle by the tan chord theorem. So the angle Q3, angle between tan and chord, this is a tan and this is a chord, angle Q3 is forming another angle T. So angle Q3 is going to be equal to angle T, tan chord theorem. So angle T is going to be equal to angle Q3, tan chord theorem. Remember, we only needed two angles to prove similarity. So we already proved the green one, angle T, is equal to orange triangle, angle Q3. Now, in green triangle, angle Q1 plus Q2 is equal to 90 degree. Why? Angle in the semicircle. We already proved. Have a look here. This is the diameter and there is a big circle, and Q1 plus Q2 is going to be equal to 90 degree angle in the semicircle, and angle P in orange triangle already equal to 90 degrees given. So this angle Q1 plus Q2 is equal to angle P. So this is my second angle. So this is the reasons. Angle Q1 plus angle Q2 equal to 90 degree angle in the semicircle. Therefore, angle Q1 plus angle Q2 is equal to angle P, which is already given. The angle P is equal to 90 degree. Both they are equal to 90 degree. So this is my second angle of the triangle. And obviously the last angle of the triangle gonna be a third angle of the triangle. Have a look here. So angle R1 is the third angle of triangle RTQ, and the angle R2 is the third angle of triangle RQP. So the R1 is going to be equal to R2, third angle of triangle. So angle R1 is equal to angle R2, third angle of triangle. Now, therefore, a triangle, now pay attention to the order of the letter. Don't worry about the top here, what we prove here. T, Q, R. T, Q, R, similar to triangle Q, P, R. Q, P, R. Reason is angle, angle, angle. Now we're going to write the proportions. So the TQ over QP, TQ is over QP is equal to first two, last two, QR over PR last two. is equal to first and the last T and R over Q and R. The reason is similar triangles. Now, in this case, we need what we need. We need to prove, must remember, we need to prove RT is equal to RQ square over RP. So actually, we're looking now. Obviously, we need a double QR, which is here. So these two we need, because double QR multiply QR is going to be QR square. So we're going to use these proportions. So we cross multiply these proportions. RT or T are same thing. So the RT multiply RP or P are same thing. We go according to the demand of the question now is equal to QR or RQ same thing RQ square. Now, so we need RT now. We need to isolate the RT. Therefore, RT is going to be equal to RQ square and then the RP under here. Both sides you divide by RP. So we proved this one. RT is equal to RQ square over RP. So the last question say if MS is equal to 14 units and PQ is equal to 640 square root units, calculate giving reasons the length of the radius of the larger circle. So he looking the radius of the larger circle. Have a look. So he's saying now MS is 14. This is 14. Now, so obviously he look PQ. He already give you QP or PQ. Same thing 640. So he looking the radius of this larger circle. So you're looking actual length. The TR is the diameter. If you find the TR, then we can divide by 2. That's going to be the radius of the major circle. So we need now actually, so we got here QP. So we need, if we can find RQ, then we can solve. Have a look here. MS is 14. The QR is going to be 28. Why? Double the MS. Why? Because according to midpoint theorem, this one is half of the length of the third side. So which means uh, MS is the half of the length of third side. So if you got this one, so which means this is, if you time by 2, then it's going to be a double of QR. So the midpoint theorem. So the MS is 14 units and the QR 28 units, midpoint theorem. Now RP square is going to be equal to 28 square QR minus 640 square root square. We apply the Pythagoras here. Let's give the reason. Have a look here. So we have the QP, which is 640 square root, and the QR we have 28 units, and we need to find the RP now. We will be finding the RP. We apply the Pythagoras. This is 90 degree. So I calculate now this 28. So I calculate it's gonna be 784 minus square number and square root cancel. So it's gonna be a 640. Square root and square number is cancel. So the 640. So it's gonna be a 144 and RP gonna be 144 square root, because the square number when switch over to this side becomes square root. So the answer gonna be a 12 units. So we got RP 12 units. Now, and earlier we proved already that the RT is equal to what? RQ square over RP. So the RQ square, which means RQ we find RQ q square is going to be 20, qr or rq, same thing, 20. So the 28 square over rp, we got now 12 already, over 12. So we simplify, the answer going to be a 784 over 12, and we further simplify, the answer going to be a 196 over 3. Now this is the whole rt. So if you look here, this is whole rt. So now if you want radius sr or st, same thing, you divide by 2. If you divide by diameter, you divide by 2, that's going to be radius. So now with this one we divide by 2, therefore the radius is equal to 98 over 3 units. This is my final answer. Please like and subscribe my channel. If you have any question, comment below. I will assist you. Have a nice day.